What would happen to you if a black hole the size of a coin suddenly appeared near you? Short answer, you'd die. Long answer, it depends. Is it a black hole with the mass of a coin, or is it as wide as a coin? Suppose a US nickel with a mass of about 5 grams magically collapsed into a black hole. This black hole would have a radius of 10 to the power of minus 30 meters. By comparison, a hydrogen atom is about 10 to the power of minus 11 meters. So the black hole compared to an atom is as small as an atom compared to the sun. Unimaginably small. And a small black hole would also have an unimaginably short lifetime to decay by Hawking radiation. It would radiate away what little mass it has in 10 to the power of minus 23 seconds. Its 5 grams of mass will be converted to 450 terajoules of energy, which will lead to an explosion roughly 3 times bigger than the atomic bombs dropped on Hiroshima and Nagasaki combined. In this case, you die. You also lose the coin. If the black hole had the diameter of a common coin, then it would be considerably more massive. In fact, a black hole with the diameter of a nickel would be slightly more massive than the Earth. It would have a surface gravity a billion times greater than our planet currently does. Its tidal forces on you would be so strong that they'd rip your individual cells apart. The black hole would consume you before you even realized what's happening. Although the laws of gravity are still the same, the phenomenon of gravity that you'd experience would be very different around such dense objects. The range of the gravitational attraction extends over the entire observable universe, with gravity getting weaker the farther away you are from something. On Earth right now, your head and your toes are approximately the same distance from the center of our planet. But if you stood on a nickel-sized black hole, your feet would be hundreds of times closer to the center, and the gravitational force would be tens of thousands of times as large as the force on your head and rip you into a billion pieces. But the black hole wouldn't stop with just you. The black hole is now a dominant gravitational piece of the Earth-Moon black hole of death system. You might think that the black hole would sink towards the center of the planet and consume it from the inside out. In fact, the Earth also moves up onto the black hole and begins to bob around as if it were orbiting the black hole, all while having swathes of mass eaten with each pass, which is much more creepy. As the Earth is eaten up from the inside, it collapses into a scattered disk of hot rock surrounding the black hole in a tight orbit. The black hole slowly doubles its mass by the time it's done feeding. The Moon's orbit is now highly elliptical. The effects on the solar system are awesome. In the biblical sense of awesome, which means terrifying. Tidal forces from the black hole would probably disrupt the near-Earth asteroids, maybe even parts of the asteroid belt, sending rocks careening through the solar system. Bombardment and impacts may become commonplace for the next few million years. The planets are slightly perturbed, but stay approximately in the same orbit. The black hole we used to call Earth will now continue on orbiting the Sun in the Earth's place. In this case, you also die. Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Where do they come from? And what happens if you fall into one? Stars are incredibly massive collections of mostly hydrogen atoms that collapse from enormous gas clouds under their own gravity. In their core, nuclear fusion crushes hydrogen atoms into helium, releasing a tremendous amount of energy. This energy, in the form of radiation, pushes against gravity, maintaining a delicate balance between the two forces. As long as there is fusion in the core, a star remains stable enough. But for stars with way more mass than our own Sun, the heat and pressure at the core allow them to fuse heavier elements until they reach iron. Unlike all the elements that went before, the fusion process that creates iron doesn't generate any energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. The core collapses. Within a fraction of a second, the star implodes, moving at about a quarter of the speed of light, feeding even more mass into the core. It's at this very moment that all the heavier elements in the universe are created as the star dies in a supernova explosion. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole. If you looked at a black hole, what you'd really be seeing is the event horizon. Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape. In other words, it's impossible. So we just see a black sphere reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? The singularity. We're not sure what it is exactly. A singularity may be infinitely dense, meaning all its mass is concentrated into a single point in space with no surface or volume, or something completely different. Right now, we just don't know. It's like a dividing by zero error. By the way, black holes do not suck things up like a vacuum cleaner. If we were to swap the Sun for an equally massive black hole, nothing much would change for Earth, except that we would freeze to death, of course. What would happen to you if you fell into a black hole? The experience of time is different around black holes. From the outside, you seem to slow down as you approach the event horizon, so time passes slower for you. At some point, you would appear to freeze in time, slowly turn red, and disappear. While from your perspective, you can watch the rest of the universe in fast forward, kind of like seeing into the future. Right now, we don't know what happens next, but we think it could be one of two things. 1. You die a quick death. A black hole curves space so much that once you cross the event horizon, there is only one possible direction. You can take this literally. Inside the event horizon, you can only go in one direction. It's like being in a really tight alley that closes behind you after each step. The mass of a black hole is so concentrated, at some point even tiny distances of a few centimeters would mean that gravity acts with millions of times more force on different parts of your body. Your cells get torn apart as your body stretches more and more until you're a hot stream of plasma, one atom wide. 2. You die a very quick death. Very soon after you cross the event horizon, you would hit a firewall and be terminated in an instant. Neither of these options are particularly pleasant. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even entered its event horizon, while you probably could travel inside a supermassive black hole for quite a while. As a rule of thumb, the further away from the singularity you are, the longer you live. Black holes come in different sizes. There are stellar mass black holes with a few times the mass of the Sun and the diameter of an asteroid. And then there are these supermassive black holes which are found at the heart of every galaxy and have been feeding for billions of years. Currently, the largest supermassive black hole known is S50014+81, 40 billion times the mass of our Sun. It is 236.7 billion kilometers in diameter, which is 47 times the distance from the Sun to Pluto. As powerful as black holes are, they will eventually evaporate through a process called Hawking radiation. To understand how this works, we have to look at empty space. Empty space is not really empty, but filled with virtual particles popping into existence and annihilating each other again. When this happens right on the edge of a black hole, one of the virtual particles will be drawn into the black hole and the other will escape and become a real particle. So the black hole is losing energy. This happens incredibly slowly at first and gets faster as the black hole becomes smaller. When it arrives at the mass of a large asteroid, it's radiating at room temperature. When it has the mass of a mountain, it radiates with about the heat of our Sun, and in the last second of its life, the black hole radiates away with the energy of billions of nuclear bombs in a huge explosion. But this process is incredibly slow. The biggest black holes we know might take up to a googol years to evaporate. This is so long that when the last black hole radiates away, nobody will be around to witness it. The universe will have become uninhabitable long before then. This is not the end of our story. There are loads more interesting ideas about black holes. We'll explore them in part 2.
Black holes are among the most fascinating objects in our universe, and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return beyond which we truly cannot see. Once something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our Sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our Sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our Sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.